It isn't another iteration of Tesla's 4680 Gen 2 cells, or a buzz around sodium-ion alternatives. What Tesla has now unveiled is their first aluminum-ion battery, a game-changing leap in battery technology that targets one of the most nagging concerns in the EV world: weight. For years, enthusiasts and skeptics alike have debated what battery would power the upcoming Model 2, but very few truly grasped how crucial reducing battery mass is in the pursuit of performance, affordability, and range. This latest battery addresses that issue head-on, shedding hundreds of pounds from the vehicle while delivering levels of performance that cast traditional lithium-ion batteries into the technological dark ages. Battery weight has long been the Achilles heel of electric vehicles, especially compact models. Consider how lithium-ion battery packs in small EVs like the Nissan Leaf weigh anywhere from 660 to 880 pounds sometimes, making up as much as 30% of the vehicle's total mass. That kind of heft doesn't just affect acceleration, it compromises handling, increases wear on tires, and drives up maintenance costs over the life of the car. For example, a 40 kilowatt-hours lithium-ion battery typically weighs about 770 pounds, which drags down efficiency and inflates production costs, directly clashing with Tesla's ambitious $25,000 price target for the Model 2. Beyond performance, heavy batteries also mean more frequent tire replacements and added service bills, increasing ownership costs by as much as $2,000 over 100,000 miles. But Tesla's aluminum-ion battery turns this equation upside down by switching to aluminum-ion technology built around ultra-thin aluminum foils. The company is reportedly achieving weight reductions of up to 50%. A 50 kilowatt-hours aluminum-ion battery could come in at just 330 to 400 pounds, essentially cutting the pack's weight in half. This breakthrough is made possible through fundamental differences in material chemistry and design. Aluminum, with its trivalent charge, Al-cubed, can store significantly more energy per unit weight compared to lithium, which operates on a single electron transfer. In gravimetric terms, aluminum-ion cells deliver between 150 and 200 milliamps per gram, compared to lithium-ion's 100 to 160. Additionally, even though aluminum has a higher density, 0.098 pounds per cubic inch, versus lithium's 0.019, its capacity to store 3 electrons per atom creates far greater energy density per pound. Traditional lithium packs also carry substantial non-active weight from casing, separators, and coolant systems, up to 40% of the total weight. Tesla's R&D efforts indicate that the aluminum-ion design reduces this dead weight by as much as 60%, turning what used to be a dense, blocky power unit into something feather-light yet powerful. According to early prototypes, the battery reduced the Model 2's pack weight by 463 pounds, comparable to removing the weight of 3 average adult passengers or a full-size refrigerator. This drastic cut opens up entirely new possibilities. Imagine a Model 2 weighing just 2,600 pounds, ripping through open highways with the agility and performance of a sports coupe, all for just $25,000. This isn't science fiction. This is happening, and the ripple effects are seismic. The technology doesn't just represent an upgrade, it's a full-scale reinvention of how electric cars are built, priced, and driven. Delving deeper, the weight-saving wizardry happens at the cellular level, starting with a complete redesign of the battery's internal components. Traditional lithium-ion cells rely on graphite anodes, but Tesla engineers have moved to pure aluminum anodes, which are not only lighter but more efficient due to aluminum's ability to transfer 3 electrons per ion. While aluminum's density is slightly higher than graphite, you need much less material to achieve the same energy output, resulting in a 10 to 15% weight cut in the anode alone. On the cathode side, Tesla is leveraging cutting-edge graphene materials. These cathodes maintain exceptional specific capacity, around 120 milliamp-hours per gram, even at incredibly high current densities of 400 AG. The result is a cathode that's not only lighter by 20 to 30% compared to traditional nickel-cobalt manganese cathodes, but also far more durable, retaining 91.7% of its capacity after an astounding 250,000 cycles. Another massive advantage lies in the electrolyte system. Conventional lithium-ion batteries depend on liquid electrolytes, which add significant weight due to the need for containment and thermal safety systems. Tesla's aluminum-ion battery, however, utilizes solid-state aluminum fluoride salts engineered with porous structures, eliminating the heavy liquid entirely. This saves an additional 5 to 10% in total battery weight while making the system inherently safer by preventing the thermal runaway conditions that plague lithium-ion designs. To support this, Tesla engineers have implemented 3D-printed structural casings tailored for maximum strength with minimum mass. By moving away from steel-heavy designs, these casings are reportedly 15 to 20% lighter, without compromising rigidity or crash safety. The combined weight savings have cascading benefits throughout the car. With the aluminum-ion battery generating significantly less heat, Tesla can reduce the size and complexity of the cooling system, shaving another 66 pounds. Environmentally, aluminum is vastly more sustainable than lithium. It's 95% recyclable, compared to lithium's 60%, and far more abundant in Earth's crust. That, along with the absence of rare earth elements, means manufacturing costs drop dramatically. Tesla estimates battery production costs could be reduced by up to 75%, bringing the cost per kilowatt-hour down to as low as $10, $20. That figure is revolutionary, putting a $25,000 electric car well within reach for millions of consumers around the world. This shift doesn't just reduce costs, it transforms performance. Tesla engineers reported that trimming just 0.1 pounds from a single cell can scale to hundreds of pounds saved across the entire pack. In real-world testing, the aluminum-ion pack reduced the Model 2's curb weight from around 3,452 to 2,987 pounds. That alone slashed the 0 to 60 miles per hour time from a projected 5.1 seconds to just 4.6 seconds without adding any motor power. The quarter-mile time dropped below 13.3 seconds, making the model to the first entry-level Tesla to achieve performance once reserved for premium models. Handling also saw dramatic improvements. The car's center of gravity was lowered by nearly 2 inches, allowing for better cornering and sharper response. On private test tracks, Tesla recorded an 8.6% improvement in lateral G-force, meaning the Model 2 can now take highway on-ramps at 58 miles per hour, compared to 52 miles per hour previously without tire squeal. Braking distances also shortened by 11 feet. From 60 miles per hour thanks to the lighter load. In emergency situations, that extra stopping power could make a life-saving difference. And it's not just about acceleration and braking. The lighter battery improves range too. Tesla's internal highway tests show that cutting 220 pounds adds roughly 12 miles of extra range. With a full 463-pound reduction, the Model 2 prototype gained an additional 26 miles, bringing the total estimated range from 300 miles to 326 on the same 50 kilowatt-hours capacity. That's over 1,300 extra miles per year, essentially a free cross-trip just from shedding unnecessary battery weight. The cost savings continue throughout the vehicle. With the reduced weight, Tesla can fit lighter suspension components and smaller brake systems, both of which wear more slowly and cost less to maintain. Tesla estimates that tire life increases by 8,000 miles. And brake pads last 15,000 miles longer, translating to hundreds of dollars in service savings. Insurance providers are also taking notice. Lighter EVs reportedly cause up to 18% less damage in low-speed crashes, potentially leading to lower premiums for owners. On the manufacturing side, lighter battery modules can be installed and serviced, with smaller equipment reducing technician labor time by 30%. That makes repairs faster and cheaper in the long run. From a customer perspective, this is not just a cheaper car, it's a dramatically better one. You're buying into a driving experience that feels more agile, offers quicker acceleration, delivers longer range, and comes with fewer hidden costs. Every component in this aluminum-ion battery has been redesigned from the ground up to deliver maximum performance at minimum cost. This isn't just a new battery, it's a paradigm shift. Tesla has taken one of the most challenging and expensive aspects of EV production and reinvented it in a way that's not only sustainable but financially viable for the mass market. As the story unfolds, the aluminum-ion battery is no longer some theoretical advancement floating in the realm of future possibility. It's here, it's working, and it's making Tesla's dream of a truly affordable, high-performance electric vehicle a reality. By cutting 463 pounds without sacrificing energy density, Tesla has crafted a machine that offers more for less speed, more efficiency, more safety, and more range, all wrapped in a sleeker, more manageable package. And all of it is headed to your driveway at a price that competes with gasoline cars. The weight of old technology is finally being lifted. With it, the road ahead for electric vehicles has never looked more promising.